Okay, we're in section 10 of the notes. That's a trigonometric form of a complex number. Again, when you're complete with section 10, that means you've done the supplemental exercises. You should also do the web assignment, Math 120, Topic 10. Also try to contribute something to the weekly discussion group, something productive, something that might help other students out with the material. So here's what we did in this section over here. We talked about the form of complex number that you were introduced in Math 100. We talked about what's called a modulus, and we covered that on the board. When I said the whiteboard, with the complex plane where we had a real axis and an imaginary axis. We talked about the form of complex number in trigonometric form, which is an important form, or polar form. Again, we did that at the whiteboard with the understanding that it's related back to the trigonometry that we've been discussing since day number 1. All right, we talked about the if we have two polar forms over here, Z1 and Z2, we talked about the multiplication and division of those numbers. We extended it to Duhamel's theorem, where we took a complex number and we raised it to a power. And we did this by squaring it, cubing it, so forth on, and then we got a general pattern to it. All right, this has been covered in class. Then we talked about taking the root, and a little more difficult, but we start taking the roots of a problem of a complex number that's in a polar form or a trig form, and we came up with a formula for that as well. All right, so then we went through some examples, and hopefully you were able to pay attention and learn from those examples that were presented to you. Of course, you need to study that material. For those students who have a hard time following lecture because it goes too quickly for them, there's also some side videos over here, and they're embedded throughout the notes. They might help you, but again, if they don't help you, please don't feel obligated to do that. However, it is incumbent upon you to master this material, right? Once you feel like you're comfortable with what was been presented to you, it's time for you to reinforce it by trying problems on your own. And that's when you get to these supplemental exercises. Again, you may want to read around a little bit, like reading your textbook, maybe in any book you have, for that matter, that deals with complex numbers, including if you have an algebra textbook lying around, they might deal with this in a way that might be different than I would do. But the bottom line is the trigonometry is going to make these problems substantially easier. What we're going to do now is the homework. I'll switch to the whiteboard. All right, 1 second. And then we'll talk about each problem separately at the whiteboard. Again, these notes should be in front of you. I'm hoping you've done the assignments already. And by doing the assignments, it should be a reinforcement of what you've done. All right. So give me 1 second. And I got to open up a whiteboard here. Okay, the notes have disappeared. And what does that mean? You're looking at my whiteboard now. All right, so the bottom line here is that we're hoping that you've done this material already. All right, now what material are we talking about? We're in section 10 of the notes, so section 10. And we're doing the homework. What does that mean? Stuff that you've done at home to reinforce what you're learning by looking through my notes and coming to class. All right. So number 1 says rewrite the complex number. I'll put this down for you. This is z equals minus 3i. What does that mean? 0 minus 3i. Back in Math 100, you would say the a is 0, the b is minus 3. All right. Now, suddenly, we're not back in Math 100, we're in Math 120. They want to rewrite this in polar form. So what I want to recommend for you to do over here is visualize it. All right, this is the real axis, and this is the imaginary axis. All right, so the real number, looking at it, the pure real number is 0. So that would be, you're not moving along the real axis, but you're moving along the complex, the imaginary minus 3. That means 3 units down. So I'll put that down for you. And I'll just go 3 units down. 1, whoops, sorry about that. 1, 2, 3. The points are right over here. First thing I'm going to do is put the angle in. All right, what's the angle going to be? Standard position, something like this. And what's that going to be? Well, it's 270 degrees. or 3 pi over 2. Sometimes I'll use degrees, sometimes I'll use the radian. All right. So I'm going to say computationally, it's probably easier to use degrees, but I'm not too worried about that. So what's this, the form they want down? They want the polar form down. So I'll write the polar form down. It's going to be z equals r cosine theta plus I sine theta. Well, I know what the theta is, but the question is, what's the r? Well, the r in this case is 3, right? How do I look at that? 3 units down, all right? All right, let's write this down now. Z equals 3 cosine, I'm going to use the radian, which is 3 pi over 2, plus I sine 3 pi over 2. Move over a little tiny bit. All right, let's get my little red pen out and grade it. And what do I see over here? I'm seeing it 3 times the quantity cosine 3 over 2 plus I sine 3 pi over 2. Looks good. Easy question. Again, this was problem number 1 in the homework. All right, I'm going to go to problem number 2. And what does it say for number 2? It says evaluate the cube of this. So let me write this one down for you. So z equals a plus bi. All right, that's a complex number you learn in Math 100. We have a polar form of this, which is going to be r times cosine theta plus I sine theta. Now, what form did they give me? Well, they gave me this the form of the number in this polar form, and so I see the 2 cosine of 75 degrees plus I sine of 75 degrees. I'm clearly seeing that. Now, what I'm going to say over here is I'm glad they gave me that because I don't want to do this business over here. I want to use this thing over here. So z to the n is going to be r to the n. We covered this in class. Cosine n theta plus I sine n theta. All right. All right. So what do I want? I want z cubed. So what's r? R is 2. It's going to be 2 cubed times cosine. Well, here comes the problem. It's 3 times 75 degrees. Well, that's going to be 225 degrees plus I sine 200, oops, put precedence, 25 degrees. All right. So if you can do the arithmetic, I would recommend doing it. And what's 2 cubed? 8. What's a cosine of 225 degrees? Well, you could leave it that way, but I think I can evaluate this. It's 1 over the square root of 2 negative. It's in the third quadrant. Cosine's negative third quadrant. And the reference is 45 degrees. Plus I, again, the reference is 45 degrees. That's 1 over root 2 for the sine. And it's in the third quadrant. And the sign is negative in the third quadrant. So let me multiply it out. And this is going to be minus 8 over root 2 minus 8i over root 2. All right, I want to keep going. Oops, sorry about that. Get my pen out of my hand. Jumps around the pens on my hand sometimes. I'm going to rationalize this. The only reason is I think the numbers are going to be written much easier. So I'm going to multiply top and bottom of these numbers by root 2. What would you get? Well, root 2 times root 2 is 2, and 2 goes into minus 8 minus 4 times. So minus 4 root 2 minus, it's the same computation, 4 root 2 I. All right, I'm going to recommend looking at the answer key and seeing if that answer is staring at you. And I'm seeing it. Yeah, but I'm carefully looking at it, by the way. I'm definitely seeing it. And again, I'm not beyond making errors. That was number 2. We're going to go to number 3 now. And number 3, ooh, the fifth roots. All right, I'll put this over here. So it's number 3. And what's a complex number? Z equals minus 2i. I want to point out the polar form is going to be easier for me to deal with So I want to put that down for you, the polar form. Again, if you don't need to do this, please do not do it. It's imaginary. All right, so what do I got over there? This is actually 0 minus 2i. So the real part is 0, but the imaginary part is minus 2. So what do I have over here? This. I have the angle. I'm going to use degrees though, because it's easier for me computationally, and I think it's easier for most students to do that. What's the angle? 270 degrees. So I'm going to write down z equals, the r is 2, times cosine 270 degrees plus I sine 270 degrees, right? There's an easier way of writing this down, 2 CIS 270 degrees. You don't have to do that, by the way. I'm not claiming that's the answer. I'm just claiming it's going to help me answer the question. Now, what does CIS stand for? Cosine 270 plus I times sine 270. Fairly simple. All right, what do they want? They want the fifth roots down. All right. So here comes the tough part. And I'll write them down for you. And the way we typically write that, we start counting at 0. And I'll write down W0. W, there's going to be 5 of them, by the way. W1, W2, W3, and W4. Fifth root of 2. 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 CIS, 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 CIS. All right. There's going to be an angle over here, and I'm hoping it's going to be really easy to write down. All right. I'll tell you what these are going to be. It's going to be 270 degrees plus K times 360 degrees over 5, where K is going to go from 0, that's a W naught, 1, 2, 3, 4, right? So let's write this down. Now, the question is, does 5 go into 270? All right. And certainly sometimes I need a calculator for that. I hope you don't, though, but I'll write it down for you. 5 into 270. And that goes 5. That's 25, 20, 54. So I'm going to put down 54 degrees plus. Now, does 5 go into 360? Well, I'm going to write that down for you too. Does 5 go into 360? Well, 7, that's 35, 72 degree times. Okay, let's take K to be 0. What would it give you? 54 degrees. And what I'm saying is K is 0, then K is 1, then K is 2, then K is 3, then K is 4. Now, if you want to put down, W5, what's going to happen, you're going to see this, it's going to go back here. It'll be coterminal with 54. Let me just go through it with you, though. So I'm going to add 72 on now, each time. Right, so 54 and 72. I'm not making mistakes here. Again, I'm doing 54 and 72. Again, the K is 1. So 54 and 72. So it looks like 126. Okay, let's do it again now. Now what I'm doing, I'm going to add another 72 degrees on. Well, I'm going to get 8 now. 9, 198 degrees. I'm going to add another 72 on. What's going to give me? Did I do that right? 54, 72. Maybe I should write that down. 54 and 72. 6, 126. 126 and 72 is 8. 26, 8. Yeah, 198. And plus 72, 270. I made a mistake somewhere. And someone said, how do you know you made a mistake? Oh, no, maybe not. Oh, yeah. What would you get? 70 plus 3 something, right? 342. Maybe not. All right, let me just see if that's true. We'll check the key later, by the way. 342 plus 72 now. Let's see, 7 and 4 is 11, right? Now I want to see if it's coterminal with 54 degrees. Take away 360, and that would be 54 degrees. Yeah, I'm feeling comfortable about this now. I thought I made a mistake. I didn't make any mistakes. Okay, so what I claim is look at the key. And I noticed in the key, I didn't really write the answer down. I wrote down what the computations were, but these are the computations over here. Of course, these can be checked on a computer as well. So I'm going to say it works out pretty nicely. I looked at it, and we are wrapping around. Again, if we kept going, I want to point out, if we had 72 to 342, I'd be back at the beginning. And they're like they say, the wheels on the bus go round and round. All right, so this one's done. Number 3 is done. Number 4. And what does 4 say? It says Z equals 10 CIS 45 degrees. And they tell me that W is 5 CIS 15 degrees. They want me to do the product, Z times W. How do I do that? Well, basically, we're going to use the polar form, which I'm been given, which makes it easy. 10 times 5 is 50 times CIS, the addition of their arguments, 45 and 15 is going to be 60 degrees, right? If you want to write down, the A plus BI, you can do that for that one because the cosine of 60 degrees is easy to evaluate. All right, let's do the next one. And again, I should look at the answer key. Let's see if they got that. Yeah, we did it. All right, let's go to number 5. Again, if you have not studied the material, none of this stuff will be making sense to you. What we're trying to get to you is you really want to study the material before you try to do homework. And I'll put down Z for you. And what's Z? Z is 10 CIS 45 degrees. Gee, it looks like the same question maybe. And then it says W. Wow, it almost the same question is 5 CIS 15 degrees. All right, what do they want to do? Z divided by W. Well, it's going to be 10 divided by 5, which is 2. Whoops. CIS, we're going to subtract the arguments. 45 minus 15 is 30 degrees. So what's the answer over here? 2 CIS 30 degrees. Again, it's pretty easy to evaluate that. But the bottom line is we're just going to see if you know the formula for that. And that's not bad. Let's see, check the answer key. Gee, I did a good job there. All right, let's go to number 6. And they want to know, can I raise this to the third power and evaluate it too? Not only just raise the third power, evaluate it. So you get 6, oops, is 1 plus root 3i cubed. Well, I'll be honest with you. If you want, you can do this. I don't recommend it, but a cube is really not bad to do. If you know the binomial theorem too, you could also expand it using that. My goal here, though, is to rely upon the polar form. I want to go over that with you. And I can write down Z for you. Is 1 plus root 3i. And I'm going to put this down over here. This is the real. This is the imaginary. And what do I got? 1 and then root 3. It looks sort of like this over here. All right, what's triangle going to be? Well, let's see, root 3, 1, 2. The reference would be 60 degrees. So I know the theta, the argument, is 60 degrees, and the modulus thing is going to be 2. All right, so the R is going to be 2. Let's polar form down. What do you get? Z equals 2 CIS 60 degrees. What do they want, though? They want C cubed. Well, this should be easy. What are we going to do? Cube the 2, which is 8. CIS 60 times 3 is 180 degrees. Now, I'm going to say that's a good answer. You kind of evaluate it. It's a nice form. But I'm thinking to myself, is it looks really too simple not to evaluate this. Let's go through this. What's going to be 8? Remember what CIS stands for. Cosine of 180 degrees plus I. That's CI. Now the S is sine of 180 degrees. Well, I think I can do that. What's the cosine of 180? Minus 1. What's the sine of 180? 0. So what do you get? Minus 8. Here's the deal. If you multiply this out, you're still going to get minus 8. All right, let's keep going. That's number 6. We'll go to number 7 now. And I gotta take a look at that. And let me, verify. Well, this reminds me of something you've done in Math 119. I9. And in 119, you were told to look for I squareds and I's in a problem. Well, what would make this I9 4? Right? 4 times 2 is 8. And 8 plus 1 is 9. Rules of exponent. What's I squared? Minus 1. What's minus 1 to the 4th power? 1. So you get I. What they ask me to do, verify it's I. If you want to do the polar form, I'll write this one down for you. Now, if I looked at I, the polar form of I would be 1 times cosine 90 degrees plus I sine 90 degrees. That's not so bad, right? I9 would be equal to 1 to the 9th power cosine, well, it's going to be 9 times 90 degrees now, right? Plus I sine 9 times 90 degrees. All right, let's do this. I9, 1 to the 9th is 1. Now, if you did, the 9 times 90 degrees, and again, you kept counting 90 degrees 9 times, you'd be, let's see, it would be like the same as cosine of 90 degrees, right? And the cosine of 90 degrees is 0. Plus I. Now, if you did this over here, this is going to be, if you did 9 times 90 degrees, and you just counted them around, you'd be coterminal with 90 degrees, and the sine of 90 degrees is going to be the number 1. What do you go there? I9 would equal I. Exactly what we expected. I'd prefer to go back to what I learned in 119 because it's so easy, all right? At least for this problem. All right, let's go to number 8. And number 8 says represent graphically, z squared, z cubed. But let me write this down for you. So z is 1/2 1 plus root 3 I. All right. And certainly I'd like to write the polar form down for you. All right. So let me put this over here for you, because it's going to be easier for me to graphically do it. And let me just, visualize it. And this is 1/2 plus root 3 over 2I. So let me see if I can visualize that to find out what z looks like in a polar form. Remember, we got a real part and we have an imaginary part. And what do you get over there? So it's going to be, half a unit in real direction and 3 over root 2. Over here somewhere. All right. And this is 1/2. And this is root 3 over 2. Pythagorean theorem, this would be 1. And the reference there would be 60 degrees. So I'm ready to write this down. What's it going to be? 1 times CIS 60 degrees. All right. Now I'm going to write down C2. We'll visualize it in a second, by the way. It's going to be rough, by the way. What's it going to be? 1 squared CIS 120. Whoops, made a mistake. That's 2 times 60. What's C cubed? 1 cubed times CIS. Well, 3 times 60 is 180 degrees, right? C4, that's going to be 1/4 CIS, well, 240, right? Okay. Let's keep going. C5, 1 to the 5th power CIS, 300 degrees, right? Because 5 times 60 is 300. Let's do C6, 1 to the 6th CIS, 360 degrees, right? And then Z7. 1 to the 7th, CIS. Let's see, that would be what? 420, right? Okay, let's visualize. What's nice about these things? Everything in front's a 1. That's a directed distance. It's got to find the angles now. So 60 degrees, I'm going to say you go out 1, it's right here. That's Z. 120. Now, what do you got? It's 60 and 60, right? That's 120. The reference there would be 60, right? So something like this. Okay, that one's done. Then I got 180. These are all 1 unit from the pole here, over here. This is going to be Z squared. This will be Z cubed. 240. Again, maybe I'm not over here somewhere. Another 60. They're all spaced 60. Let me just make sure I understand what I'm doing over here. This is 60 degrees. This is 60 degrees. This is 60 degrees. This is 60 degrees. Well, that's not so bad. I got to go 300 now. Oops, I got a black pen out. And again, I want to put the pace spacing in here at 60 degrees. They're going up by 60. And this is going to be what? Z4, Z5. And I like the way I could say the wheels on the bus go round and round. Then we got Z6. That's going to be 360. Over here. That's Z6. And Z7, right? They're all spaced by 60, right? I'm back on the beginning. So Z is the same thing as Z7. We just visualized it. All right, that's number 8. So let's go to the next one up, which is number 9. Write this down for you. And they give me Z1 equals root 2 plus root 2I. Well, I still want to visualize this in sort of like the real, the imaginary part of it and find out what the angle is and all that kind of nice stuff about it. So I get the polar form down. All right. So root 2. Well, reference is 45 degrees, right? So I know the theta, the argument for this one is 45 degrees. Called Z1. And let's see, what would the R be? It's the modulus, right? So it's root 2. So it's going to be root 2 squared is 2, and 2 plus 2 is 4, and the square root of 4 is 2. So I'm ready to write down Z1 is 2 CIS references 45 degrees, right? All right, let's put down Z2 now. A little more complicated. This is going to be 5 halves plus 5 root 3 over 2I. And again, I'm going to try to visualize it. But by that, I mean, I'm looking at the imaginary and the real part. Again, this is the imaginary. And this is the real. Hopefully they're nice, really nice numbers. So let's take like 5 halves and then 5 root 3 over 2. 60 degree reference. So I'm going to say theta 2 is 60 degrees. All right, real simple stuff. Let's do our Pythagorean theorem now to find out what the R is. That's going to be 25 quarters plus 75 quarters. If I squared it right, that's 100 quarters. And if you took the square root of 100 quarters, you get 10 halves, or 5. All right, let me erase that work over there. I'll put down the R as 5 now. So Z2 is going to be 5 CIS 60 degrees. All right. So someone's going to say, what are you going to do now? By the way, if you want to use the radians, pi over 4 is 45 degrees, and 6 degrees would be pi over 3. All right. I'm using degrees because it's easy for me to do computation. They want me to do Z1 times Z2. Well, that should be easy. It's 2 times 5 times CIS. We're adding the arguments together. What's going to be 105 degrees. What does this give me? 10 CIS 105 degrees. I'll put this in a box. All right. If you want, and you want to convert it to the radian, I want to point out this is pi over 4, and this is going to be pi over 3. If you add pi over 4 to pi over 3, you would get 12. 3 plus 4 is 7 pi. All right, so I'll write this one down too, if you prefer. We'll check the key later. The reason for that key is we always want to encourage you guys to fess up to errors, just like your teachers should fess up to their errors. So I do Z1 times Z2. I did that. And what do they want to do? They want to do Z2 minus Z1. I'm sorry, Z2 divided by Z1. Well, that's going to be 5 over 2 CIS 60 minus 45, right, is 15 degrees. All right, I'm going to write this one down. And we got Z2, which is pi over 3 minus pi over 4. Again, it's going to be 12. I'm using the radian now for the students that did that. And then you get 4 minus 3, which would be 1 pi. So what's this one going to be? 5 halves CIS pi over 12. Okay, let me look at the answer key. And I want to, certainly see if I've got it right. And let's take a look. And they're not using the CIS notation, but it's really the same thing. So let's look at the Z1 times Z2. I see the 10, and I do see the CIS. They just write it down as cosine I sine, and it's 7 pi over 12 in their notes, which same thing as 105. Next one, 5 halves CIS. They do have the cosine I sine pi over 12. Same thing as 15 degrees. Let's go to number 10. And number 10 says, find the 3 cube roots of Z equals 2 plus 2i. Well, again, I got to get that complex form down. So I just want to remind you what I mean by that. Again, if you need to visualize, that's fine. 2 over, 2 up. That reference is definitely 45 degrees. So I'm going to put this over here. And 2 squared is 4. So 4 plus 4 is 8. So the r is going to be the root of 8, or if you prefer, 2 root 2. All right, I kind of like the root of 8 though. All right, so let me write this down for you. So the r is the root of 8. And then CIS 45 degrees. All right. Here comes a tough question now. What do they want you to get? They want you to get the cube roots. All right, so it's going to be W0, W1, W2. All right, so I'm going to write R down a little bit different. I'm going to write it down as 8 to the 1/2 power. That's what R is. Now, what goes in front of here? It's going to be that 8 to the 1/2 to the 1/3 power. So it's going to be 8 to the 1/6. CIS, CIS, CIS. All right, let's write this down. 45 degrees plus 360-degree K over 3 with the understanding K 0, 1, 2. All right, let me simplify this. This would be 15 degrees plus 120 degrees K. Let's take K to be 0. You get 15 degrees. Then I go up 120. That's going to be 135 degrees. Then I go up 120. What would that be? 135 to 55 degrees. Now, if you go up another 120, let me write this down for you. Let me see, 5, 7, 375. Well, that's really back at the beginning, the 15 degrees. It's coterminal with 15 degrees. So I'm going to put a box in this indicating we're done with it. All right. I realize what some students want to do. They want to maybe evaluate these guys over here. And I'm going to say you don't have to, but I guess you could. I think they evaluated them too. And I want to point out it's really not a bad evaluation. For example, 15 degrees, you could use a half angle form to do that. Don't feel obligated to do that, by the way. 135 is super simple. 255, I guess what you could do there is, I guess you could use a sum formula. Let me see. Or maybe the 310. 255. Oh, I'm sorry. I didn't mean to say 310. I'm thinking of an easy way to do it. 255. And that would give you what? 255 times 2. $255. Let me just think for a second. I'm going to make sure I did that right. 120, 240, 255. $255 would be 180. 75 degrees. Yeah, 75 degrees. And then you could do 60 plus 15 and figure it out. I'm going to say, I'm not going to go through the arithmetic with that. It's sufficient to what we did over here. Let me just see. Yeah, we did that. And I don't think I'd go much further than that. But I guess we could. In the notes, I noticed I put a lot of numerical work down there. But I'm satisfied with the CIS. All right. And I'm satisfied with the numbers they've written down over there. And let me just make sure I did that right. 2, 8. Yep. Looks good. All right, let's go to the next one, number 11. And, solve an equation. I'll write this one down here, x to the 5. Now, what you learned in Math 119 is the 5th degree polynomial. There's going to be 5 roots. Now, certainly, I hope you know there's some roots you could easily come up with in this one over here, but we're going to have all 5 roots. So what I write down is, x5 equals 1. And what I'd like to do is just write down, I want the 5 roots of 1. So I'm going to say z equals 1. And what does that mean in a complex plane? That means, 1 CIS. And what angle would you get there if it was 1? I want to point out what I'm doing. I'm visualizing. This is the real. This is imaginary. And the CIS would be what? I mean, it just would be 0 degrees, right? Put this over here. All right. So why do you like degrees? It's easier for me. All right. So I can start writing the roots down. All right. So W0, W1, W2, W3, W4. Well, it's going to start out with the 5th root of 1, which is 1. CIS, 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 CIS. All right, let's go for the angle. Okay, so it's going to be 0 degrees plus 360 degrees K over 5, where K 0, 1, 2, 3, 4. Doesn't look that bad. So I'm going to do 5 into 360 first. And that's going to go at 7 times, right? 35. This is deja vu, isn't it? 72 degrees. So it's really 72 degrees K. Let's do it. Well, if K is 0, this would be 0 degrees. If K is 1, this is 72 degrees. I'm going up by a very simple number, 72 degrees, 144. 72 degrees up, get 6, 7 and 4, 11. 72 degrees up, 88 and 2. Right. Let me just check it. 288, another 72. That would give me 10, 16. Yep, I'm back to the beginning. I'm back to a coterm with 0. So I'm going to claim that's the answer. And of course, I want to point out that stuff is written down for you. I did the arithmetic here for you. I noticed in my notes I didn't do the arithmetic. But anyway, this is it. We're done with that. Let me go to number 12. And that is x to the 5th power plus root 3 plus I equals 0. Well, this is going to have 5 solutions to it. I'm looking for the 5 roots of this number over here. So write down z for you. Z is minus root 3 minus I. I'm going to visualize that for you because I want to come up with this, the argument and the modulus. So minus root 3 minus 1. So let's see, over here somewhere, right? What's the angle going to be? I'll be careful too. Let's take a look. Minus root 3, that's the real, minus 1. It looks like 30 degrees for the reference. So it's going to be, the theta is going to be 180 plus 30, which is 210 degrees. Now let's do the r. That's going to be, 3 plus 1, which is 4, square that is 2. That's not so bad. So z is going to be 2 CIS, let's see, 210 degrees. Okay. Now what I'm going to do is write down the 5 roots. First one is W0, W1, W2, W3, W4. All right, so it's going to be 2 to the 1/5, or the 5th root of 2. 5th root of 2, 5th root of 2, 5th root of 2, 5th root of 2. CIS, we'll do the angle later. CIS, 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 CIS. Let's do the angle. 210 plus 360 degrees K over 5. I guess 42 plus 72 degrees K. All right. Understanding K, 0, 1, 2, 3, and 4. Well, the first one of 0, I'd get 42 degrees. Then I go up by 72. Let's see. I guess that's going to give me 6 degrees, right? 72 and 42. I'm sorry, that's not 6. Let me erase her out. 72 and 42, 4 degrees. Whoops. 4, 111. I'm sorry, 114. Now there's 72 degrees up, 6 degrees, and if I went up 72, that would be 18 now. Another 2 degrees up, 7 degrees up, that's going to be 8 degrees now here, and 250. All right, another 72 degrees up. We'll check these, by the way. Let's see, that would be 60, 330. Now let me write this down, 330 and 72, which is going to be 402, right? And if you took away 360 from that, I want to make sure it's coterminal, by the way, 42 degrees, exactly what we expected to come up with. So I'm pretty comfortable with these. These are correct answers. Again, we'll look at the answer key. And I noticed that they didn't do the arithmetic in the answer key, but we got this all done. All right, so we completed the homework now. And I want to just briefly talk about Sage. So give me 1 second. I'm going to go back to my share. And let me just do a new share with you. And I think I'm here. And I'm going to open up Sage for you. Remember, if you can't run Sage from a terminal, which a lot of students have a tough time doing, they have a tough time installing software, a tough time even using software. Web-based software is not bad, by the way. And what I mean by that, you go to the Sage, sagemath.org, and click on the CoCalc. And CoCalc, you'll be able to do exactly what I'm doing here. The only difference is I'm hitting a return key on my computer. On your computer, you would be hitting the shift return. All right. So yeah, simple things like, sign of, let me do option pi, pi. If I did that, let's see what happens. Yeah, pretty simple computation, right? So let's go back to the Sage, and I'm gonna clear it first. I'm gonna reset. I'm going to clear out the memory because I did a problem I don't remember doing. Let me do square root of -1. Remember, if you're using CoCalc, you'd have to hit shift return. I'm just hitting the return. It says uppercase I. So now I know the uppercase I indicates the imaginary unit number. All right. Let me do I squared. Gee, exactly what I expected. Exactly what you told Math 100. If I did something like this, 1 divided by 2. And what's the next number going to be? Plus 1 divided by 2 star I. We actually did this one in class to the 10th power. Let's see what happens. All right, so 1/32 of an I. All right, let's do this one over here. X equals var. Now in Sage, X is already a reserved variable, but I want to point out it's a good habit to write down that X is a variable when you're doing a problem. Something you may not have seen before unless you took courses with me, but I'm going to say assume X is a complex number. All right. Now, someone says, what's your computer going to do now? It's actually loading a package for complex number or solutions to problem over here. So let me write this one over here, solve x to the 6th power. And again, the computer's now thinking that it's a complex number, which is good. All right. So let me return. And I want to count them up for you. So I have 1, 2, 3, 4, 5, 6 numbers. All right, 1 is really obvious though. X, if it's 2 to the 6th power 64. Well, what did they do? They wrote down all 6 solutions to the problem. All right, now let's do another one. This is familiar to me, it's a problem we just did in the homework, solve. And again, I know a lot of students are arguing, if a computer did this, why do I need to learn how to do that? You need to learn how to do simple things. Complicated things, typically a machine is going to be much better at. But again, if you can't do simple things, you'll never get to the computer stage. All right. Yeah, there are complicated numbers there. We've actually did that problem. All right, I think that pretty much closes it out. And I want to emphasize here, please look around. Try to learn this material. Try to spend a lot of time studying this material. All right, thank you so much.